Good morning, guys. Today we're going to finish 10.1 sequences in series. After the class, we're going to talk about the exam. So let's get to the class first. The first thing we're going to see is convergence or divergence. This is pretty much a definition, and it's a pretty straightforward definition. If you remember end behavior, what value does y approach as x approaches infinity? We could have gone as x approaches infinity, y approaches infinity. As x approaches infinity, y approaches negative infinity. And as x approaches infinity, y approaches a particular value. Many times it's 0. So pretty much, when it goes to positive infinity or negative infinity, or pretty much any time it does not approach a particular value, it is divergence. When it approaches a single value, in this case 0, it will be, there's a convergence there. And again, you can see a couple of examples of convergence. You can have something that looks like exponential decay. Sometimes the values are even going to be popping up or down, but they all will end up approaching 0 after a while. Remember, they might not reach 0, but they approach the value 0. So again, if they approach the same value, in this case 0, there's convergence. If they approach different values, divergence. Now, there are two ways you can test for this. One is arithmetic, but that takes a very long time. The second one is plug in the formula you're given into your graphing calculator, hit graph, and just evaluate the function that represents that formula. Now remember one thing, a function most of the time is going to be an interrupted line, most of the time. But even though the actual summations might be integers or whole numbers, you can still evaluate that function and see if there is convergence or divergence of values. Okay, perfectly fine. So again, that's pretty much theoretical. Plug it in, evaluate. If the value is approaching 0, convergence. If it's not approaching 0, divergence. Pretty straightforward. The next one is the partial sum. Now here's where we're getting into actual, what series is. If you remember yesterday, sequence is an ordered list of numbers. That's what we call a sequence, an ordered list of numbers. Series is the actual summation of all the values within the sequence. So again, sequence is the order list of numbers. Series is the end result or the summation of all those terms within that sequence. So that's the definition. Now there are two ways we can add those values, using sigma, which I will explain later, or using the nth partial sum. Now, the nth partial sum is represented by the letter Sn, n being the actual term. So if I give you S3, that means I'm going to add the first term, the second term, and the third term. Stop there. That's going to give me my series for this particular nth partial sum. You can see the examples in page 593. Okay, they give you S4, you're going to add the first 4. They're going to give you S2, you're going to add the first 2. Now, this is great when you want to begin adding from the beginning. If I want to begin adding from the beginning, yeah, makes perfect sense. It does make sense, but it's confusing. If you want to add all the numbers from the beginning to a particular point, then we can just use straight up partial sum, because partial sum always begins in the first term. Doesn't matter what value it is. Doesn't matter where it's located. It always begins at the first term. It begins at the first term and it adds everything until I reach the nth term that I want. It could be any number. That's adding the first 17 terms. Now, in some situations, you do not want to begin in the first value. I want to add values 10 through 14. I want to add values 3 through 6. Those are the only ones that you want for a particular study. I want to add values 10 through 20. In this case, we do not use partial sum because partial sum, again, begins in the first term. So it would add the first 9 terms. I guess you could do like a sort of difference. You add the first 9 terms, then you write that value down. You add all the way up to 17 and then subtract. But I mean, that's very inefficient. So when we're going to add particular ranges of terms that do not include the first one, we use sigma. And it looks very complex, but it's not. It's the exact same thing as this. This is the Greek letter sigma, and it stands for, summation in math. It has an upper bound and a lower bound. Here, I set the lower bound as 1, but the lower bound could be any number. One thing to keep in mind is the lower bound has to be smaller than the upper bound, because here, the lower bound tells me where I'm going to begin adding, and the upper bound tells me where I'm going to finish adding. So again, here I'm going to begin at the 3rd term, and let's make it easier, and I'm going to finish on the 7th term. So I will not be adding the 1st or 2nd term. And as you can see here, it tells me I add all the, in this case, since it's a 3, this would be a n to the 3, a n to the 4, and I'm going to finish at a7. So again, the n represents the lower bound where you will begin, which is called the index, if I'm not mistaken. Let me confirm. N is the index. That tells you where you're going to begin counting. And K up top is the upper bound. Again, you can think of it this way. Lower bound, it's at the bottom. At the bottom of sigma. The bottom is where you're going to begin. Lower, less. At the top is where you're going to end. Upper, more to the right. So I'm going to begin on the lower side. I'm going to end counting on the upper side. You repeat the formula that many times. One thing, remember, these formulas could be 2 things. It could just be a straight up formula, in which case you will actually plug the numbers that you were given, 3, 4, 5, 6, 7. Okay? So when you're not given the actual term, there is no recursion. This was a question I was asked yesterday. When they're giving you just the plain old n, that means if it's the 6th term, you're going to add a 6 there. If it's the 7th term, you're going to add a 7th there. As soon as you see this, again, this represents term, for example, there's where recursion happens, because you're plugging in actual terms, previous terms, into the formula, not numbers. Okay? So that's pretty much it. Convergence and divergence, partial sum, and also sigma. Pretty straightforward. Easy class. I love this particular chapter because it's very puzzly. You can sometimes tell what these sequences are just by visually, coming up with the answer. Now for homework, please do 18 through 20, which is just plugging those formulas into your calculator and stating convergence or divergence. Pretty straightforward. Example 5, I want you to do 28 and 29. Again, that's good enough. And for sigma, 36 and 37. Again, pretty straightforward. These are convergence or divergence. These are adding the whole series or sequence starting from 1. And this is using sigma from the index to the upper bound. That's it. Now that's it for the class. Now for the exam, the exam is going to be on Monday. I will be uploading a practice test on Wednesday, probably, or maybe tomorrow. And you'll have the entire weekend to study. Normally, under normal circumstances, I don't give you guys exams on Monday. But this is a particular situation in which you guys will be home And that gives you the entire weekend to call up and ask questions if you have questions. Please don't save all your questions for Sunday at 9:30 p.m. because I might be talking to other people. Schedule your calls. Schedule your calls. It's fine if you want to call on Sunday at 9:30, but schedule it on Saturday just to make sure that no one's taking that time slot. Don't schedule it at 9:27 p.m. because the slot might be filled up. And again, perfectly fine to call me with any questions, any doubts about the test. The test will be what we've seen in vectors. Now it's going to be a difficult test, somewhat, because again, you got to go over the heading, the different types of describing the directions, the vector breakdowns. It includes identities and trigonometry. So you're going to have to review a bit. I still don't know if the test will be a live test or a quizzes test. I'm not sure yet. What I'm thinking I'm gonna do is I'm gonna do it as a quizzes test. Only I'm going to do 4 or 5 different tests, and then send a small group of students those particular codes. And I think that's going to be it. I will give you more details for the test on Thursday when I know how it's going to be. Just know it's going to be on Monday. Besides that, after that, we're going to have, just to give you guys the breakdown of what's missing in the quarter, we're going to finish sequences and series until probably not the entire chapter, but we're going to give a good block of the chapter. We're going to introduce limits, and that's going to be a test. We're going to introduce limits and derivatives. I know exactly where I want to get to there because it's very important for your next year in calculus. And we're going to give a test, and that's it. We're going to do a project with the remaining time. So you have the vector test, you have sequence and series test, you have the limits and derivatives test, and then we're going to end the quarter with a project. So after we give the last test, it's all going to be project till the very end. If you have any questions, comments, just want to let me know what you think. I'm open. If there are no questions, make sure you turn in the homework before 11 p.m. Stay tuned for tomorrow's class. And for the reviews on Thursday and Friday, Saturday, Sunday, that's pretty much it. Have a great day. Take care, guys.